Hi students, I'm Neeraj Bansal and welcome back to the Math Navigator. Today we are diving deep into the topic vectors. If you have been struggling with this topic or finding yourself stuck on the methods, remember a golden rule. Stop guessing, start navigating. Before we jump to the topic, a quick heads up. If you need personalized help to crush your upcoming exams, I offer one-to-one session. My contact number is right there in the description below. Please feel free to reach out. So let's start it. In last class, we have done, or in the last video, we have done augmented matrices. What was the use of augmented matrices? You need to see my video. The link for the video is given in the description below. So in augmented matrices, we have seen that when we solve a equation in two variables, that is two simultaneous equations, or equation in three variables, that is three simultaneous equations, we can have unique solution, we can have no solution, or we can have infinitely many solutions. But today we are going to talk about the equations in two variables because we are talking about a line. We can have two-dimensional lines or three-dimensional lines, right? So in two-dimensional lines, let's say this is one line and this is another line. So there can be three possibilities, or there can be three relations between the lines. The lines can be parallel, right? The lines can be parallel, or the lines can intersect at a point, or the lines are coinciding with each other. Got it? So when the lines are parallel, we say no solution. When the lines are intersecting like this, we say unique solution. Or when the lines are coinciding, we say infinitely many solutions. I hope this is clear. Once we do a certain question, then we will. So let's take some question, right? So let's take this question. Right. So basically what this question is saying, we have already seen how to solve the augmented matrices. So in this 2 by 2 equation, first I'll make my augmented matrix and then I'll see what is happening with this. So let's go for it. 3, 5, negative 3, 9, negative 30. As we have discussed in the video that we have to make this 0, right? How can I make it the 0? R2 times e by 2 minus R1, right? That will replace R2. Let's solve it. So 3 by 2 times R2 will give me 3 by 2 times 2 minus 3 by 2 times 3 minus 3 by 2 times 30, right? So this will give me 3. This will give me negative 9 by 2, and this will give me 13 3s are 9, so minus 39 by 2. And then we have to subtract this, so 3 5 9. So let's change signs, right? So this will give me 0, and this will give me negative 9 by 2, negative 5, which will give me negative 19 by 2. So negative 19 by 2 And mm, sorry, this will give me negative 19 by 2, and this will give me negative 9, negative 3 by 2, negative 39 by 2. So this will give me negative 18, negative 39 by 2, which will give me 17, negative 57 by 2. So negative 57 by 2. So my this row will be replaced with, let's put it this color, 0, negative 19 by 2, and negative 57 by 2. So this means I have 0x minus 19 over 2y is equal to minus 57 by 2. So I got 9, minus cancels, minus 2 cancels 2. So y is equal to 57 over 19, which is 3. So I got y is equal to 3. Got it? Then I will place this value of y in either of the equation, or in at the top of the equation, which is saying 3x plus 5y is equal to 9, which will give me 3x plus 5 times 3 is equal to 9, which will give me 3x plus 15 is equal to 9. It implies 3x equal to 9 minus 15. It implies 3x is equal to negative 6. It implies x is equal to negative. So I've got my x as negative 2 and y as 3. So the point at which the two lines will intersect is negative 2 comma 3. This is the point at which lines will intersect. Perfect. We have got this, right? Now let's talk about another question, right? I'm doing this also. Let's want to do more questions, because see, in IB you need lots of practice. So I have prepared worksheets for you. You can send me a message if you want to do more practice, so that I can send you those worksheets personally, right? So what does this mean? This, we have to find the value of k, right, where k is a constant. What does this mean is, that means it can have different types of solutions, depends on the value of k. So let's first solve it and then we'll see what happens. Again, I'll create my augmented matrix. 1, 4, 3, 12, 5, k. Again, I want to make this thing 0. This thing 0, this 0. So what I can do is R2 minus 4R1. Right? So my R2 is 4, 12, and K. 4R1. So 4, 3 4s are 12, and 5 4s are 20. I'll put negative, 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 because signs are changing. So now I got 0, 0, and this is k minus 20. So I'm replacing this row with this. I'm having now 0, 0, k minus. So from here I will get 0x plus 0y equal to k minus 20. So if k minus 20 is equal to 0, that means k is equal to 20. Then there are infinitely many solutions. But if um, this k is not equal to 20, that means k minus 220 is equal to something, right? If k minus 20 is equal to something, that means k is not equal to 20, then there are no solutions. Got it? Right. So this is the relationship between two lines, rather I should say two lines which are lying in a plane, right? That means two-dimensional lines. But what if there are three-dimensional lines? See, there can be three things. Either they are parallel, or they are intersecting, or they are skew. Skew means neither parallel nor intersect, right? So parallel means their direct, if the direction vectors are multiple of each other, that means vector b1 is equal to k vector b2, then they are parallel. Intersecting means if they have unique solution. And skew, that means if they are neither intersecting nor unique solution, we call them not. Now there is another very important thing: minimum distance between two three-dimensional lines. See, we have said that minimum distance is the perpendicular distance, right? If I have lines which are three-dimensional lines, so I'll say these are two three-dimensional lines, right? And I want to find the minimum distance between them. So minimum distance between them is perpendicular. So if I'm saying point A and B is lying on the two lines, if I find magnitude of AB, that should be my answer. So what I need to do here is I need to make the equation of this line. This line. So let's say this is my direction vector, right? So my direction vector will be this. How will I get this direction vector? This direction vector is uh, this direction vector. I can, let's say this is line L1, this is line L2. This direction vector can be found out by cross product of direction vectors of L1 and L2. Got it? Right. And then we can take cross product with, we can take the cross product with direction vector of L2. I'll do one question, then you will understand. Right. Let's come to the question. Let's take this. So basically, if I make the vector, these are the two skew lines. Let's say this line is L1 and this line is L. I'm making L1 and I'm making this L2. And I want to find this vector, and the cross product of these vector should be some multiple of this. That means vector AB is equal to k times cross product of the vectors of the direction vectors of the two lines. I'll just make it. So let's say vector equation of L1. Let's take vector R1 is equal to t1 minus t, and so I'll take 0, 1, 2 plus t times 1, negative 1, 1, right? And vector R2 equal to t negative 1, 4 plus s times negative 1, 2, negative 1. Got it. So now I have to take the cross product of these vectors, right? So vector s cross vector t, this is the cross product. Let's call it vector, let's call it vector a. So cross product of vector s cross vector t, that means I have to do the cross product of 1, negative 1, 1 cross negative 1, negative 1. I want to find the cross product of these two vectors. So how do we find the cross product? I, j, k, right? 1 minus 1, 1 minus 1, 2 minus 1. So I cap, then minus 1 times minus 1 is 1, minus 1 times 2 is 2, minus j cap. 1 times minus 1 is minus 1, minus of minus, that is plus 1, right? Then k cap, 1 times 2 plus 2, right? So I cap, so this is how we'll make this. So minus I plus, this is 0, so plus k cap. So this is the vector product of these two vectors. So my vector A is equal to this. Got it? So now, as I can see, now what I'm going to do, the cross, now the dot product of this vector, this is my, this vector A, right? So the direction vector of line, this is the direction vector of line AB, right? So if I say vector AB, first I'll find vector AB. So vector A is a general point on line A and B is a general point on line B. So general point on line A will be 0 plus t. General point on this line will be 0 plus t and 1 minus t and 2 plus t, right? And general point on this line will be, this is my vector A. A is a general point on this and B is a general point on this. So this will be 3 negative s negative 1 plus 2s 4 negative s. So I need to do vector B minus vector A, which will be vector AB. So let's do that. So vector AB is equal to vector B to vector B minus vector A, which will be how much? Which will be like C minus S minus 1 plus 2S 4 minus S, right, minus of 0 plus T, minus of 0 plus T, minus of 1 minus T, and minus of plus T. Will give me T minus S minus T, that is minus 1 is minus 2 plus 2S plus T. This will be 4 minus S, so 4 minus 2 is 2 minus S plus T. Got it? So this is my vector AB. Now this vector AB is some multiple of vector A. Why I'm saying this? Because if you go by this, let's say the diagram. This is A, this is B. And if I'm taking the cross product of the vector, this is the cross product vector, which is vector S cross vector T. So they are in the same direction, vector AB and this, but the lengths are different. So I can say vector AB is equal to K of vector A. So I'll write vector S as 3 minus S minus T is equal to, and my this vector was I cap. So vector A is equal to, I'm writing here, actually it is written already here, so I'll just minus I. So this will give me negative K, sorry, negative K, which is equation 1. And then you have minus 2 plus 2S plus T is equal to 0, because J is 0. And then you have 2 minus S plus T is equal to K. So these are three simultaneous equations in three variables. Right, got it. So if you solve them, you will get S is equal to negative half and T is equal to 3. You can solve it directly on the calculator, or you can solve it manually also by using augmented matrix method, which we have already understood. Now you have to put this value here. So vector AB will come up with, that means you have to substitute the value of S here and T here. So it will come up to half 0 negative half, right? So this is my vector AB. Now if I want to find the length of the line, I'll just do magnitude of vector AB, which will be under root of half squared plus half squared, which will give me under root of 1 by 4 plus 1 by 4, which is equal to 1 over under root. units. It can be anything, right? So this is how we will solve this question. This is a little bit, yes, will take a little bit of practice and then you'll be able to, right? So in the next video, we will be talking about planes, right? So now what you need to do is you need to go to my channel and see all the previous videos, because what I'm doing is I'm making detailed videos on every topic. So in vectors, we have done introduction to vectors, then we have done videos on line, then we have made videos on augmented metrics, and then we'll make videos on plane. If you watch it, then only you'll be able to understand. All right. So please subscribe my channel.